Hello viewers, you are welcome to my YouTube video. Today I'll be solving a problem under the topic limiting value of a function, and the problem is to find the limit as x approaches infinity of 2x to the power of 3 minus 3x to the power of 2 plus 4x minus 1 divided by 4x to the power of 3 plus 7x to the power of 2 minus 3x plus 8. So we go to the solution. Now I'm going to solve this problem by showing you two methods, and you're at liberty to use any one that you feel comfortable with. The first method, we're going to write the limit as x approaches infinity of the entire content of this bracket. But prior to finding the limit as x approaches infinity, we need to reduce the numerator and denominator to a value that we can easily evaluate. So the first method is to divide each and every one of the four components of the numerator by the value of x with the highest exponent, which is x to the power of 3. So I will factorize x to the power of 3. I'll open a bracket, and then I'll pick this value, 2 times x times x times x, signifying 2x to the power of 3. X times x times x signifies the factor we brought out, which is x to the power of 3, and then we divide the common factors at the numerator and denominator. So we have x times x times x divided by x times x times x. They both cancel out, and then we are left with 2. So I'll write my 2 over here, and then I'll clean this up. I pick this sign, the negative sign, I write it here. I pick the next term, 3 times x, signifying 3x to the power of 2, and then the denominator x times x, standing in for x to the power of 3. And look, we cancel the common factors at the numerator and denominator. So x to the power of 2 cancels x to the power of 2, which is x times x, cancels x times x, and the fraction reduces to 3 divided by x. So I write it here, and then I clean this up. I pick this sign, plus. I pick the next value, 4 times x, standing in for 4x. X times x stands for x to the power of 3. The common factor at the numerator cancel the common factor at the denominator, and the fraction reduces to 4 divided by x to the power of 2. So I'll write it here. I'll clean this up, pick this sign, I'll write it here, and then I'll pick the last value, 1 divided by x times x, and since we don't have any value of x at the numerator, the denominator remains same, x to the power of 3. So write it here. So I clean this up and I close the bracket. I move to the denominator. I pick the first term at the denominator, but before then I need to factorize the common factor. Remember, I told you earlier that I'm picking the value of x with the highest exponent. What I did at the numerator, I'll do same at the denominator. So I will factorize x to the power of 3, and then I'll open a bracket. I pick this value, write it here, 4 times x times x divided by x times x, which is x to the power of 3, and this value stands for 4x to the power of 3. So the common factor at the numerator cancels the common factor at the denominator, and the fraction reduces to 4. So I'll write my 4 here, and then I clean this up. I pick this sign, I write it here. I pick the next value, 7 times x, standing in for 7x to the power of 2. X times x stands for the factor which we have factorized, the value we factorized, x to the power of 3. The common factor at the numerator cancels the common factor at the denominator, and the fraction reduces to 7 divided by x. So I'll write it here. I clean this up, pick this sign, I'll write it here, which is the negative sign. I pick the next term, 3 times x, standing in for 3x, and x times x stand for x to the power of 3. The common factor at the numerator cancels the common factor at the denominator, and the fraction reduces to 3 divided by x to the power of 2. So I'll write this here, and then I'll clean this up. I'll pick this sign, I'll write it here, and then I pick the last term, 8, which is 8 divided by x to the power of 3. Of course, no value of x at the numerator, and so the fraction remains 8 at the numerator divided by at the denominator x times x is x to the power of 3. So I write it here. I'll clean this up and I'll close my bracket. So looking at the numerator and the denominator, you agree with me that x to the power of 3 is common. So the common factor at the numerator and denominator cancels out. So x to the power of 3 cancels x to the power of 3, and the fraction it has been reduced to the simplest form. This is one method, so you can adopt this. Alternatively, you can decide to divide the numerator and the denominator by x to the power of 3. Of course, where x to the power of 3 stands for the value of x having the highest exponent in the entire bracket. So we write our limit as x approaches infinity. We open our bracket, and then we write all the values, each of the 4 components of the numerator and each of the 4 components of the denominator, divided by x to the power of 3, as I've mentioned earlier, being the value of x with the highest exponent. So I'll reduce this to a form similar to this. So I'll have x to the power of 3 cancels x to the power of 3, because these are the two are common at the numerator and denominator. So I'm left with 2. I move to the next fraction. So I write it in a clearer way, the way I did for the previous step. So 3x to the power of 2 stands for 3 times x divided by x to the power of 3 has been written as x times x times x. So the common factor at the numerator cancels the common factor, another value cancels this value because they are common, and the fraction reduces to 3 divided by x. So x to the power of 2 divided by x to the power of 2 is 1. 1 times 3 is 3. X to the power of 3 divided by x to the power of 2, because that's the common factor at the numerator and the denominator, as we can see here. We'll be left with 1x. So that is 3 divided by x to the power of 1, similar to what we have here. So I'll clean this up. I'll move to the next fraction. 4 times x standing in for 4x. X times x times x stands for x to the power of 3. The common factor at the numerator cancels the factor. The common factor at the numerator cancels the factor that is common to at the denominator, which is x, and then this fraction reduces to 4 divided by x to the power of 2. So x divided by x is 1. 1 times 4 is 4. X to the power of 3 divided by x will be left with x to the power of 2, as we can see here. And then we clean this up. We'll move to the next fraction. Of course, there's nothing to be done here, so we'll leave it that way. And then at the denominator, x to the power of 3 cancels x to the power of 3, because both are common at the numerator and denominator. We may move to the next fraction, which is 7 times x, standing in for 7x to the power of 2 divided by x times x, standing in for x to the power of 3. The common factor at the numerator cancels the one that is common at the denominator. So x cancels x, x cancels x, and then the fraction boils down to 7 divided by x. So x to the power of 2 divided by x to the power of 2 is 1. 1 times 7 is 7. X to the power of 3 divided by x to the power of 2, you'll be left with x, which is equivalent to x to the power of 1. And you can see this fraction is similar to what we got here. And then we'll move to, I clean this up, we'll move to the next fraction. I write it in a simpler term. X cancels x, because x is common at the numerator and denominator, and the fraction boils down to 3 divided by x to the power of 2. So if we are to reduce this fraction, x divided by x is 1, and 1 times 3 is 3. X to the power of 3 divided by x, you have x to the power of 2 left, which is similar to what we got here. And then I clean this up, and this fraction remains the same because we don't have any x at the numerator. So you can see what we got here is similar to what we got in the first step. So we'll move to the next slide, and then we'll find a limit as x approaches infinity of the entire value we got. This was what we got from the method 1 and method 2 of the previous slide, and I told you you're at liberty to use any one of the two methods. You don't need to show the other one. I had to show both so you could make your choice as to which one is easier for you to use. Now, from the value we have here, we need to find the limit as x approaches infinity of each and every one of the 4 components of the numerator and each and every one of the 4 components of the denominator. So I'll write it out this way. Limit as x approaches infinity of 2 minus limit as x approaches infinity of 3 over x plus limit as x approaches infinity of 4 divided by x to the power of 2 minus limit as x approaches infinity of 1 divided by x to the power of 3, and then to the denominator, limit as x approaches infinity of 4 plus limit as x approaches infinity of 7 divided by x minus limit as x approaches infinity of 3 divided by x to the power of 2 plus limit as x approaches infinity of 8 divided by x to the power of 3. Now we need to resolve each and every one of these 4 components of the numerator and each and every one of the 4 components of the denominator independently, and that was why we had to attach the limit as x approaches infinity to each and every one of the terms. Therefore, we pick the first term. The limit as x approaches infinity of 2 is 2. The reason is because the limit as x approaches infinity of a constant is a constant. Take note. And then we'll move to the next term. But in solving this, I will factorize these 3 out here. So I'll have 3 times the limit as x approaches infinity of 1 divided by x. Take note, the limit as x approaches infinity of 1 divided by x is 0. So 0 times this constant 3 is equal to 0. And that was why the entire fraction, the limit as x approaches infinity of 3 divided by x equals 0. And the same thing holds true for multiples of x. So if I have 1 divided by x, 1 divided by x squared, 1 divided by x to the power of 3, 1 divided by x to the power of 4, we will attain the same answer. It will still be equal to 0, provided x is approaching infinity. And then if you use the entire value to multiply a constant, of course, 0 times any constant will be equal to 0. So we'll move to the next term. I factorized. I had to take out the 4 at the numerator. I brought it here to multiply the value I'm going to get here. So limit as x approaches infinity of 1 divided by x to the power of 2 is 0, and we use it to multiply 4, it will still amount to 0. We pick the next term. Limit as x approaches infinity of 1 divided by x to the power of 3 is equally 0, as I've mentioned earlier, because x to the power of 2, x to the power of 3, they are all multiples of 1 divided by x, because 1 divided by x to the power of 2 is same as 1 divided by x times 1 divided by x, which is equal to 1 divided by x to the power of 2. This is equivalent to 1 divided by x times 1 divided by x times 1 divided by x. So since 1 divided by x equals 0 as x approaches infinity, if you are looking for the limit, then the multiple of 1 divided by x will also be equal to 0. Then we'll move to the denominator. Limit as x approaches infinity of 4 equals 4. As I've mentioned earlier, the limit as x approaches infinity of a constant is the constant. I'll pick the next value. Limit as x approaches infinity of 7 over x. So I factorized 7 out here, and so of course we know the limit as x approaches infinity of 1 divided by x is 0. 0 times 7 is 0. And then we'll move to the next value at the denominator. Limit as x approaches infinity of 3 divided by x to the power of 2. So I picked the 3, I wrote it here. And then 1 divided by x squared is a multiple of 1 over x. So since limit as x approaches infinity of 1 divided by x is 0, so limit as x approaches infinity of a multiple of 1 divided by x, which is 1 divided by x to the power of 2, will also be equal to 0. So 0 times 3 is 0. And then for this, limit as x approaches infinity of 1 divided by x to the power of 3, which is a multiple of 1 over x, will also be equal to 0. And so we have it as 0. Hence, this algebraic fraction reduces to, the first value reduces to 2 minus 0 plus 0 minus 0 divided by 4 plus 0 minus 0 plus 0, and we can write it in a clearer term as 2 divided by 4. And if we are to divide this by the common factor at the numerator and the denominator, which is 2, 2 divided by 2 is 1, and then 4 divided by 2 is 2. So if we look at this problem, we finally figured out the solution to the problem. And so the limit as x approaches infinity of 2x to the power of 3 minus 3x to the power of 2 plus 4x minus 1 divided by 4x to the power of 3 plus 7x to the power of 2 minus 3x plus 8 is equal to 1 divided by 2. I do hope this solution was simple enough for you to understand. We appreciate if you like my YouTube videos, and then you comment if any, and we appreciate if you share it with your friends, and so much so that they could also have access to some of the videos that you are watching. We sincerely appreciate that. So thank you for watching my YouTube video. See you next time.